on. Just a minute. Okay. Okay. So yesterday we stopped it here, like, discussing about the collections and yeah. So we were in that hash set and hash map and tree map, we just discussed about what exactly these things. And I told you, like, I'll get an examples for these things and with some, comparable. Okay. Yeah. So let us continue from there. Okay. I have several examples with collections and yeah, one example with the comparator and how to sort them. Yeah. So let's go with that. And later, we'll check for the last one. The parallel processing and the functional programming. So I can give a couple of examples, like, one for parallel processing using int streams, and the other one is stream API. The other one is functional programming. So I'll just, introduce one, how to write some lambda expression and the basic example of the lambda expression. So yeah, it's like more code way only. Okay, so I'll show you how to write them, and you can continue to practice that. And if you have any questions, to let me know. Okay, so let me.
So, so what kind of technology?
Yeah, so one second. Okay, so let me start with the collections only. So yesterday we discussed about array list and yeah, one second. Yeah, yesterday we discussed about array list and linked list, right? So let's go with now hash map first, and then hash set, and then tree map, and then the comparator example. And in the comparator, if we are using with the streams, so how we can achieve this comparator using streams. Okay, that also I'll tell you today with an example. So we'll start with hash map first. Okay, so hash map, if you guys remember, like, I told you, like, whenever the data whenever the data is in format of keys and values. Okay, so we have to so we have to use hash map, kind of collection, because hash map provides that kind of data structure, like, can we can store keys and values in it. Okay, But how do we store, right? There is hash map. If you see here, so what I'm doing here, I'm creating a hash map object. Okay, so with you know certain what kind of data that I'm expecting in the first position. Okay, and what kind of data that I'm expecting the second position, right? So the first position, whatever you are seeing, it is string, and the second one is integer, right? So what you see in the string is a key, okay, for the integer. So this is a key and this is a value. Okay, so what I'm going to do, so I'm trying to add elements into the hash map using put method. So put method is a predefined method which was defined in the hash map. Okay, so you can utilize that put method to add elements to the uh, you know created hash map. Okay, so I'm just adding couple of elements. Okay, one is John, Jane, and Tim, with that 25, 30, 35. So this is as defined. Okay, so we have added these things, okay, into hash map. Okay, and then I'm trying to print one of the value which I have just added. One is like hashmap.get, okay, John. So when I say hashmap.get John, so this is we were utilizing key, okay, to call the value. Okay, so what we are trying to do, we are just utilizing John, okay, as a key, and we are getting the value of 25. So uh, so this is the key and this is the value. Okay, so how do you remove something from the hash map, right? So hash map provides default methods like as put, we have dot remove also. So dot remove will delete that particular, okay, object, or that particular key with corresponding value. So entire this thing will be deleted when you use remove method. Okay, okay, so then what I was just trying to do, I'm just checking. There are multiple methods that we have it in hash map. That is, one of the method is dot contains key. Okay, so what it is telling, like, the contains key will take the parameter as the key name, and it goes and check in the hash map whether that key is exist or not. Okay, so that contains key will be giving you either a true or false. If you see here, and I mouse over, actually on the top you see returns true if the map contains a mapping for the specified key. Otherwise it is going to return false. Okay, okay, so in this case what I'm trying to do, I'm trying to get the gym which is here, but unfortunately we already deleted that element, so the output we are expecting is false. Okay, so let's see. And the next one, I'm just printing that hash map dot size. Okay, and so hash map dot size will give you the output as to, because we already removed one of the one of the element from the hash map. Okay, second, just a minute. Okay, Okay, I'll show you what was that, and I'll just give me a second. Okay. What was this map? Just a minute, guys. Okay, I'm just writing. Okay, I'm just adding just entry set for that. Okay, so that we can run that. Just a minute. Okay, yeah. So okay, sorry, 1 second. Okay. So I was just checking only for that entry set. Okay. So to print that entry set. Okay. So what exactly this entry set prints, Hannah? It gives you all the list of keys and values, whatever hash map is having set view. Okay. So if you run this program, we'll be able to understand it. Okay. So Java example hash map. Okay. Okay. So the first actually what we have done. So when you go and check back, John 25, that was our first element. So what we're trying to do, we are trying to get the John key. Okay. Okay. So what was the value in it? It is 25. So we got 25 for that. And the second one, we just removed hash map dot remove. Okay. Jim. And yeah, so it should, we were not, printing anything for the remove. But after removing, actually, we are trying to call that contains key of Jim. So the output is false, and we are getting it as false. Okay. And the next one, we were checking of the size of the hash map with the current list. Sorry, with the current size. So it is 2 because we removed Jim and we got the size as 2. And we just call that entry set. Okay. So entry set, what it is going to give, so it will give the set of values, whatever we have it in that hash map using the key and value pair. Okay. So yeah, this is how, the hash map works. Okay. And it has a lot of other methods also. You can just go through them and you can, utilize iterator, and you can use for each loop, to print all the keys and values also. So you can do that way as well. Okay, so just explore the methods, whatever you have it in HashMap, and you'll be able to understand, you know, inside of HashMap. Okay, so let me go to the next one. Example hash set. So hash set is also like, so yesterday we learned, right, about hash set. So the first main point is actually about hash set. Right? So whenever you wanted to add some duplicate objects, how set is going to stop, we'll check it today. Okay. Yeah. So in this case, actually, I took this examples from Google itself. So, but I will try to explain what exactly it is doing. And this example has set, okay, is having, we declared a hash set which called h, and we were saying that, it is going to take a string as a, into that set. Okay. So what I'm trying to do, I'm just adding elements using h.add. So add is the method which was provided by hashset. Okay. So to add elements. Okay. uh, so whenever I try to add 3 elements first, with the name, with the string, and after that I'm trying to add h.add. Okay. So if we add this one, so what exactly it is going to give? So it is going to generally give a Boolean value, but I did not printed that. Okay. I'll once after my first execution, I'll try to print it. Okay. So let's see how it is going to execute and all. Okay. And then what I'm trying to do, I'm just printing the entire hash set. Okay. And I'm just printing, the one which we have, whether it is India is present or not. It is going to give you this contains method is going to give you whether it is true or false, like, If the method, if the value that we are looking for is present in the set, it is going to give you a true. Otherwise, it is going to give you a false. Okay. So how to remove, right? The same way, whatever we have it in hash map, actually we have this remove method in the hash set. So you can remove it, okay, using that h dot remove. Okay. So, and iterating over the list. Okay. So I was just like having this iterator, and I just use while loop. You can use any for each and everything, you can use it, and you can print it. Okay. So let me run this program. Example hash set. Okay. So what it was trying to say, first it printed all. Okay. First it printed all. This one, system.out.println h, and then it was printed true for this one because we have India, and list after removing Australia. So we have South Africa and India, and then iterating South Africa and India. Okay. So now let's see what exactly this is going to print, right? Okay. So it should be printing false, right? Okay. See, it printed false. Why it is printing false? It tried to add this India element, to the existing hash set. What it why it is rejecting? Because India is already there. So it is not going to allow you a duplicate element. Okay. A duplicate element into the set. Okay. So that's why it returned false, and it never added that India again to the hash set. Okay. So that's how it is going to stop the duplicates, okay, in the hash set. So whenever you required something duplicate, so without duplicate elements, okay, go with hash set. Hash set is going to work very proper in the stopping duplicate elements. Okay. And so let me go to the tree map. Okay. So in the tree map, actually we have in the tree map, we same as like whatever we have it in the hash set. So we do have similar kind of methods to add elements, and to get elements from the tree, and to remove elements. And also you can do the iteration using the same way. Okay. So what I was trying to do now, I was just adding just creating a tree map, okay, with a string and integer. Okay. So I'm just adding an element. Okay. Tree map dot put, this is a and 1. Okay. So whenever you wanted to get a element of that node, right, so you are going to get call with the a. Okay. So how do you get that values from the tree map? The same way, whatever we have it like get method in the tree map. Okay. So utilize that and get it the value of it. Okay. And we have the similar kind of remove method. Okay. So the remove method is, one second, sorry. Yeah, just a minute. Okay, so remove method is going to remove that, whatever the value that we have provided over here, it is going to remove elements from the tree map. Okay, and yeah, iterating, it is very simple. So whatever the tree map that you are going to get it, just get that key set and, iterate, with the values. Okay. Okay, let me run this program. Java example tree map. Okay, so the first one is value of a equals to 1, and then it removed that b value because we used remove of b, and then it printed for each loop, it printed all the values whatever we have it in the tree map. Okay, so it was very very simple. Okay, similar to that. And let me go to the comparator. Okay, so in the comparator, okay, so I have used a student class, okay, which is having two data elements in it. Okay, data, one is roll number and one is the name and address. Okay, and let us see how to sort these things from based on the roll number and also the string name. Okay, so what I've done, actually I just created a couple of methods in the student class. One is having a constructor which is going to assign all the values of the data members, roll number, name and address. And the next one, I just added a toString method, to this is for the display purpose, I just added it. Okay, and let's see now how to how to okay, how to make it a sort. Okay, sorting in an ascending order for the roll numbers. Okay, so what I've done, actually I just created another class called, yeah, so created another class called sort by roll number, which is implementing comparator. Okay, and I'm passing which class. Okay, so it is going to work on, so that is student class. Okay, so what I've done, I just implemented the compare method. Okay, which is there in the comparator interface. Okay, so uh, uh, the compare, I'm passing the two objects of student, one is A and B, and what I'm trying to do, I'm returning the you know I'm returning the yeah, sorry, I'm returning the value of the difference between those two rule numbers. Okay, so that it is going to sort all the student related data based upon the roll numbers. Okay, so let's see how it is going to sort it. Okay, and the same way I was trying to do for the string. Okay, so string means like for the student name, based on the student name. Okay, so in this I was trying to use the compare to method. Okay, so it is going to compare two strings. Okay, and it is going to return which one is greater, like so generally what it does, actually it is going to return int. Okay, if return 0, it is the same exact object. Okay, if it is written -1 or 1, okay, so it is going to positive integer, you know positive integer or negative integer. Based upon that, it is going to sort, okay, the strings in the student. Okay, in the student student object, like whatever the objects whatever we are passing, so it is going to sort them based upon the values which is it is going to return by compare to method. So we'll see, once we have the values. Okay, so we'll see. So let's see here. So what I'm trying to add it over here, I'm just trying to add list of elements. Okay, into a student object. Okay, so there are multiple, I have just added 4 students. Okay, and I'm trying to print this first. with an unsorted. So it is going to print all the values, whatever the order which we have added into the array list. Okay, it is going to print them. Now, what I'm doing actually, I'm trying to utilize collections.sort. Okay, using the sort by roll number. Okay, so what we are passing the array list for it. Okay, and it is going to print all the sorted by roll number. Okay, and so let's see how it is going to print it over here. Okay, and the next way, we were trying to utilize that sort by name method. Okay, which is going to sort it by then based on the names of the students. Okay, so we are passing this array, so it will be sorted, and when we are trying to print them, actually it should print the sorted sorted array list. Okay, so let's see how it works. And okay, so if you see here, the first one is unsorted. Okay, so which was the same order whatever we have added into the array list, uh, in the first time. And the second one, it it is, sorry, in the second one actually it is going to sorted by roll number. Okay, so the order actually it has been changed, so it just sorted into the 101, 111, and 121 and 131. Okay, okay, and then after that we are trying to sort it based upon the name, right? So if you see here, Agarwal is, having the first position, and even though we have sorted by name, but Anshul, right, 131, it came up here. Okay, and Solanki, okay, so it went to the down, and Mayank came a little up. Okay, so it sorted based upon the name. Okay, so this is how you implement comparator. Okay, comparator. Okay, and how to use that compare method, and how to implement that compare method, okay, in the comparator class, and how to use whenever you are trying to compare a string or something. We usually use compare to method, to compare those strings. Okay, based upon the values, how whatever the values it is getting, it is going to, like, sort it based upon the output of this compare to. If it is a negative value, it is going to sort it based upon the string which is greater, and positive if it is equal, it is going to say that it is same as the same string, so it is going to return 0. So based upon this, a comparator can sort it, and keep those objects in a sorted order. Okay, any questions on this? Yeah, before going for the next example. Okay. Okay, so stream comparison. Okay, so when you utilize, if you are using, get than Java 8 or something, we have streams concept also. So you can utilize this comparator, using streams. Okay, so let's say, I have one list. Okay, which is having some int values. Okay, in it. So 5 minus 10, 7 minus 18 and 23. Okay, so which is having most, unsorted order. Okay, so I was just trying to sort it in a reverse way. Okay, so let us run this program. What I've done, actually, I just you know took that list and called the stream method. Okay, and in the stream, actually, we have this dot sorted. So how do you sort it? Based upon the comparator interface. So in that, actually, it provides a couple of methods. Okay, so Okay, so one is the method which is called reverse order. So what it is going to print, it is going to print, uh, you know, uh, the values in the descending order. Okay, and for each, right, what is the for each loop? Actually, it is going to print all the elements, whatever we have it in the array list. Okay, okay, so this is how you write a syntax. Okay, this is a syntactical way, whenever you are using streams. Okay, you write in this way. Okay, so list dot stream, it is going to get all the values. Okay, sorry, so this sorted one, actually what it is going to give you, the complete statement, it is going to give you a sorted elements of this array list, whatever we provided. Okay, so let me run this. Okay, so the higher value to lower value, so it is like descending order. Actually, I think we were using reverse order, right? So yeah, so if you want to utilize the natural order, so just use this natural method. So it can be, yeah, it will be printed on the natural order. Okay, Java. Okay, so the lowest value to highest value, -18, -10, and 5, 7, 23. Okay, so any questions on this? Okay, okay, in that case, let me go to the next one. Okay, so we have discussed, we already discussed about this one, parallel processing and functional programming yesterday. Just the basic of it, and let me try to give you an example. Okay, about this. So yeah, let me go with the parallel example first, and then we'll go with, I think we already saw an example of stream, how you utilize that stream in whenever you wanted to use the comparable. But I have one more example with the predicate. Okay, so how much easy that you can search values in the predicate. Okay, using you know the stream. Okay, I'll let you know that. Okay, so before that, we'll go with parallel example. No, first we'll go with lambda expression. Okay, so I just took only very basic things from the lambda expression. Okay, this is where that Java has been introduced, the functional programming. Okay, so when it is very simple example. Okay, so I have created an array list. Okay, which is having multiple values in it. So I just added with using add method. And what I'm trying to do, I'm trying to utilize for each loop. Okay, and what exactly this is going to do, right? So in the for each loop, what I'm trying to do, I'm just trying to get this values, right? I wanted to print everything. Okay, so with the help of functional programming, I've just added this lambda expression. Okay, uh, there is a value integer n. Okay, because what we have declared, we have declared that this list is going to contains an integer value. Okay, so I'm just utilizing this operator. Okay, okay, and just printing system.out.println. So what it is going to do, it is going to reduce. There are 4 different steps that we have to write it if you wanted to use for each loop, right? So either one is you have to get, the iterator of the array list, or, you have to utilize, like, you have to create each and every integer object, and, you can just write it in the system.out.println saying that, okay, this is what I want. This is, the value that we are going to get it, array list dot, you know, so something like this, right? There are 4 steps. What we need to do, you can utilize something like this for each. And which one is array list? Sorry. Yeah, iterator, and you take that iterator and you utilize in that for loop and printing those elements, okay, from each iterator has next, and we were doing to print that next value over here. So this, whenever you utilize this program, right, sorry, this lambda expression, so it is going to remove all those steps, four steps, whatever we are going to write it, iterator. And once that iterator has next and next, we were utilizing that methods, to define whether we have an element or not. So but when you are using lambda expression for printing elements, it is very easy, like, you just define what kind of value that you wanted to print it, and that for each loop will help us, to iterate the entire list, and it is going to print in the output, okay, the console. So same way, if you wanted to print some even elements, okay, so you can write, the condition itself, inside the inside, using lambda expression. It is very easy. You can just utilize it, something like this for each, okay. And what type of element? It is integer, and what you are trying to do, you wanted to print, the even elements, right? So this is the condition that I'm going to write it, and then print it is, okay. So simple, right? Like, you don't require to create a separate method, or you don't require to create, separate logic. So you can just open, anonymous method, okay, directly in here, okay. And you can write whatever the logic that you wanted to, and you can close that, okay. So let's see how it works. Java. Okay. So it printed 1, 2, 3, 4, and here it should print only 2 and 4. So it printed 2 and 4, right? So very simple. So do we we can use this lambda expression in so many places, okay? Like, not only at the printing side, whenever you wanted to do some kind of logic, uh, you know, in you can utilize this lambda expressions, okay. Um, so it is basically, to get everything into the functional programming, okay. So so if you have any questions, do let me know. I'll try to, give you, I'll clarify them. uh, if you don't have anything, I'll go for the next example, parallel example and stream example. Okay. Yeah. So this is the parallel example. Okay. How you can achieve parallel processing. Okay. Using streams. Okay. So what I'm trying to do, actually, I'm just trying to print the numbers between 1 comma 15. Okay. So I just took that int stream. Okay. So I was trying to utilize, the normal way, so without using parallel. So I was just, iterating, all those values from 1 to 15, and I'm just printing it. Okay. And when it comes to the parallel way, so I just call that range dot parallel. Okay, for each, and I'm printing all those values, whatever we have it in the in stream. Okay. So, so let me try to run this first. Okay. And I'll show you. Okay. So if you see here, in the normal way, actually it followed very sequential order, to, get those end stream values, okay, from 1 to 15. But when it comes to the parallel, actually it is, you don't see any order here, right? Why? Because actually the parallel processing is continuously picking up, okay, at one on the one go. Actually, it is going to picking up, okay, all the elements, okay, and it is printing the elements in the parallel way. So that's why you don't see any order for this, the parallel processing. Okay. So if you wanted to get some order for the parallel processing, yeah, you can still do that. So using range 2 dot parallel with the sorted, and for each also, even, okay, so let me show you something. Okay, I'll just remove this for each ordered. Okay, let me run this one. Oh, okay, one second. Okay, so let me run this. So, sorry. Okay, so even though I use that sort method, okay, sorted method, okay, but still, it is not, printing the sorted values, when we use for each. Okay. So because, for each is not going to give you, the ordered elements until unless you utilize that new method for each ordered. Okay. So let me put it back for each ordered, and let us run this program again. Okay. Java parallel example. Okay. See now, so it is printed in a order way. Okay. So when we really see the difference is, okay, so this parallel processing will help us in multiple places. Okay. So let us consider an example. Okay, we are trying to call multiple services. Okay, and that services will give you a kind of output. Okay, so let's say you are exposing a service. Okay, and this service will give some output to the client, right? But internally you might do lot of operations, okay, to get that output, to the client, right? So let us consider you are calling internally five different other services, to generate the output, okay? So calling those five different services in a sequential way, which will increase your SLA, right? Like let's say, the client is expecting a response from you, from your service is like, 2 seconds, okay? And you are internally calling five different services, and those has to complete within that 2 seconds, and you have to prepare that output and you have to send it back to the client within 2 seconds, right? So let's say if one of the service was taking at least 1 second, to respond to you, right? So in that case, what we are trying to do using this parallel processing, you are going to call all the services at one time so that it can complete in that 1 second itself, okay? If you go with sequential order, so you are taking almost like 2 seconds for calling all those five services, and you are not able to respond back within SLA, like within 2 seconds, to your client, right? So if you are going with a parallel processing, so you can achieve that 2 seconds SLA very easily, okay? So how you are going to do? At the same time, you are going to call all the services at one place, okay? Using the parallel processing, okay? So with that, what it is going to happen, whenever the program execution starts, okay, whenever somebody calls the service, so all the five services will be hit at the same time, and when we get the response, actually it is going to combine them, and it is going to utilize, it is going to respond back to your client within that 2 second SLA, okay? So to implement these things, actually we need to we need to go through very like what do we say, very, yeah, sorry, we need to go through, there are certain methods, there are certain steps that we need to follow whenever we wanted to achieve this parallel processing. So go through those parallel processing related examples, or the classes, whatever it is providing using streams and all. If you have any questions on it, do let me know. I can help you guys, okay? I know to understand them properly, okay? And you can, but whatever the examples which I'm providing, it is very basic, to cover them, like we have these kind of concepts in Java, and that's why I was not going very deeper in it, okay, because I need to cover a lot of things, okay? So if you really have any questions, okay, I'm ready to help you, okay? And from tomorrow, actually we will going to discuss the new topics, okay, related to Git and all, okay? So let me know if you have any questions in the Java perspective. Yeah, I'll try to resolve them, okay? Otherwise, if you don't have any questions, so okay, so we can wind up the session.